Okay, so let's take a look at a couple other different examples. So it says we have a rectangular prism and we want to find the measure of angle ABC. So if you look at that, from A to B is going to go right through the um, like diagonal of the prism, and then A to C is going to go down through there. So really what we end up having, this angle right here, angle C, is a right angle. So we end up with this triangle here of A, B, C, and we know C is a right angle. And we know BC is 14. Um, but what we do not know is AC. But we can find it. That's the angle we're looking for, ABC. And if you look at this side here, we know this is 6 and this is 11, and then that diagonal is AC. So I can use what we call Pythagorean theorem. This is A and this is C. This is 6 and this is 11. And so I can find that value there by using Pythagorean theorem. So we have 6 squared plus 11 squared is equal to x squared. And when I add those two together, I get 157 is equal to x squared. And so our AC is going to be the square root of 157. So I'm going to label that as the square root of 157. And now we have enough information to find theta. So this is my opposite and this is my adjacent. And so I can do tangent there. So we have the tangent of theta is equal to the square root of 157 over 14. And then we have to do the inverse to get rid of that tangent. So do the inverse on both sides. And that gets rid of my tangent. So I have theta is equal to tan to the negative 1 of the square root of 157 over 14. And when we calculate that in our calculator, we get 3 sig fig 41.8 degrees. And so angle ABC, so we could say the measure of angle ABC is 1.8 degrees. And that's your answer. Okay, let's take a look at one more example here. So now we have this prism, not a prism, sorry, pyramid. And we want to find the angle that is between the slant height of AX and the base diagonal AC. So we know that we have this ABCD, ABCD, and we know this is our diagonal here. That's a right angle. And these are all, it's a square because of those tick marks. And so we can again use Pythagorean theorem to find the distance of AC. So we have 32 squared plus 32 squared is equal to AC squared, which gives us 2048 when we add that together to get us AC squared, and then you square root both sides. And so AC is the square root of 2048. Okay, so then we have to think we want, we're talking about AXC here. And so if I draw that, AXC, and I can drop a perpendicular line here to give me a right angle. We know that this part is going to be half of um, our square root of 48 to 2048, excuse me. So if we look here, this is A and this is X, and here's our 90. This side is going to be half of the square root of 2048. And then I also know that this is 58 because of those tick marks. And so I have, we want to find angle A there. And so this is my, this is my adjacent side, and this is my
Abe Lewis
opposite.
to the front office,
No,
please.
that's not.
Abe Lewis to the front office, please.
This is my hypotenuse. So we have cosine. So we have the cosine of theta is equal to 1/2 times the square root of 2048 all over 58. And when we do inverse cosine on both sides, those cancel, and we end up with theta being 67 degrees.